This video is recorded to help my students to understand the concept of recursive and how to write algorithm use recursive control. Okay, let's give an example. Write algorithm to calculate the factorial of n. So let us first understand what is factorial of n. Factorial of n in math, the notation is n factorial equal defined as n multiply n minus 1 multiply n minus 2 and multiply, keep going, multiply 2 multiply 1. Basically, where n is a positive integer number. So basically, n factorial is defined as use all those product of all the numbers from n go down to 1. Okay, or you say from 1 go up to n. So for example, 5 factorial will be defined as 5 times 4 times 3 times 2 times 1, which we know is 120. Also, 3 factorial is defined as 3 times 2 times 1, okay, which is 6. Okay, so that's the definition of factorial. Of course, mathematically, we also define 0 factorial equal 1. Okay, now this is the regular definition for factorial, but we can define factorial using recursive think. Recursive think, which means recursive definition is you use this thing itself to define itself. So if you observe carefully, you say n minus 1 multiply n minus 2 multiply 2 multiply to 1. This equivalency is n minus 1 factorial. For example, 5 factorial actually is 5 times 4 factorial because 4 times 3 times 2 times 1 by definition is 4 factorial. So that tells us I can define n factorial as n times n minus 1 factorial. So for example, 5 factorial can be defined as 5 times 4 factorial. Why? Because 4 factorial by definition is 4 times 3 times 2 times 1. Then after you multiply 5, of course, it's 5 factorial. So you notice I use factorial concept to define factorial. This means recursive definition. Now, here is a problem. Recursive definition, if you only define like this, then people are asking you to write out n factorial. You might say you can never stop because no matter what is n, you always have n minus 1. Then n minus 1 is n minus 1 factorial is n minus 1 multiply n minus 2 factorial. So you have to, n minus 2 factorial is n minus 2 times n minus 3 factorial. So you can keep going. So you must have a stop point. So in the recursive definition, we call this is recursive part. Then we must have a base part, which is where your recursive stop. So we say 0 factorial equal 1. That is the base. Now, based on that, now we can use this definition to recursively write out, for example, 3 factorial. 3 factorial by the definition is 3 times 2 factorial because 3 minus 1 is 2. Then by the definition, 2 factorial is 2 times 1 factorial. Then by the, right, because 2 factorial is 2 times 2 minus 1 factorial. Then by the definition, which is 3 times 2 times 1 times 0 factorial. Now, notice at this point, by definition, 0 factorial is 1. So I don't recursive anymore. Since 1 times anything is that thing itself. So 0 factorial since 1, multiply 1, nothing change. So I can ignore it. So eventually the answer is 3 times 2 times 1. So you say recursive definition will give you the same result as you use line recursive definition. But when you use recursive definition, you just notice you have a base part, base case. Sometimes we call base case, which is your recursion stop. Now, then how do you write recursive algorithm? So for example, I say procedure factorial of n, right? When you write this procedure for the recursive, you always first write a base case. So you can say if n is 0, then you return 1. That means 0 factorial is 1. So you use if statement, right? If you don't return, that means if n is not 0, n is a positive integer greater than 0, then you will say, otherwise, you don't need otherwise, you just say return n multiply factorial of n minus 1. Now, notice this is you factorial recursive algorithm is inside of this algorithm, you call this algorithm again. So equivalency, this sentence equivalency n factorial is n times n minus 1 factorial. That's exactly the explanation, exactly is the statement about this factorial definition. Okay, so the recursive algorithm actually is kind of easy to write. You first write the base case. You just say, in the base case, what is the result? Then you will write, if it's not a base case, what is the result? This time you will use recursive call, like here. What is n factorial? It's just simply n times n minus 1 factorial. Okay, let me stop here to get your feedback.